BCHCT 133 Chemical Energetics, Equilibria and Functional Group Organic Chemistry 1 Volume 1 Chemical Energetics and Equilibrium Block 1 Chemical Energetics Block 2 Chemical and Ionic Equilibrium BCHCT 133 Chemical Energetics, Equilibria and Functional Group Organic Chemistry 1 Block 1 Chemical Energetics Unit 1 Chemical Energetics Basic Aspect Unit 2 The First Law of Thermodynamics Unit 3 Thermochemistry Unit 4 Second and Third Laws of Thermodynamics Chemical Energetics In the first block of the course, you would learn about the basic aspect of energetics, the laws of thermodynamics. Their significance and applications. This block contains 4 units. The first unit deals with the basic aspect of chemical energetics and covers terminology of thermodynamics, the concept of heat, work and heat capacity, thermodynamic reversibility, thermal equilibrium, and the zeroth law of thermodynamics. The second unit deals with the first law of thermodynamics, its explanation in terms of internal energy, heat changes under different conditions, and application of the law to the gaseous system undergoing expansion under isothermal and adiabatic conditions. The third unit takes up thermochemistry and covers the energy changes accompanying chemical reaction and their measurement, the concept of thermochemical equation, standard enthalpy changes, bond enthalpy, and the variation of enthalpy changes with temperature. The fourth unit of the block deals with the second and the third laws of thermodynamics and covers spontaneous and non-spontaneous processes, criterion for spontaneity, concept of entropy, Gibbs energy, chemical potential, absolute and residual entropies, and statements and significance of second and third laws of thermodynamics. In the next block, we would take up chemical and ionic equilibrium. Objectives. After studying this block, you should be able to define chemical thermodynamics and outline its significance. Explain the meaning of work and heat and discuss their interconvertibility. Explain the concept of thermodynamic reversibility with the help of suitable examples. Explain the concept of internal energy and enthalpy. Outline their significance and the relationship between them. Derive mathematical expression for the work of expansion of gases under isothermal and adiabatic conditions. Discuss energy changes accompanying chemical reaction under constant volume and constant pressure condition and their experimental determination. Explain the effect of temperature on the enthalpy of a reaction and derive the Kirchhoff's equation. Explain spontaneous and non-spontaneous processes and state the criteria for spontaneity. Explain the concept of entropy, Gibbs energy and chemical potential and outline their significance. State and give significance of the second and third laws of thermodynamics and define and differentiate between residual and third law entropies.